I have several devices that I'm now going to control and talk about how they're all insecure. It's great. Hi, I'm Jasper. I'm a White Hat member. I'm giving a talk tonight on mobile security. I'm going to talk more about security at the platform level, so kind of at iOS and Android, the operating systems, before Charnpreet talks a little bit about dividing your apps to be secure kind of against attackers on your own services. So if you make your own app, you don't want someone to own your web server. So, who am I? I'm a computer science student. I'm a second year. I have mobile devs experience. For a couple summers, I worked for my dad doing mobile apps. Not on the store. They're the kind of apps that you would see at special events like trade shows and at conferences. Have any of you guys been to Staples Center or the StubHub arena down? You have? Nathan's gonna nod his head. If you guys have been there, have you guys ever seen the StubHub like ticket booth where they print out those little tickets for you? People had lanyards now. Oh, well, we wrote that app. So if you ever go back there, they're going to be using it for a while. You'll see it. So we wrote those kind of apps. And I'm also very recently, as in today, a White Hat officer. It's great. So I'm going to be talking about, like I said, security on the mobile platform. So what am I talking about? I'm going to talk about iOS and Android primarily. It turns out that exploits against mobile phones have been around for a while. Some of you in like middle, elementary school, you guys have those old slide phones. Some of you maybe high school if you're older. The ones that had like really crappy operating system that was like kind of like Android, but before Android. Those apps and like the swiping through. That was usually Symbian, which was an earlier kind of like proto-smart OS. That thing got hacked horribly. Like by the time Android rolled around, Symbian was just full of holes. I'm not going to talk about it because it's old and nobody uses it anymore. But best of you know, if you find one of those old things, you can hack that thing like crazy. Interestingly enough, did you guys know that both Android and iOS are based on Unix systems? So iOS is an extension of OS X, which probably surprises nobody, which is BSD. Android's actually Linux. I think they're up to the most recent Linux kernel these days. So it's the Linux kernel wrapped with a bunch of code that Google wrote, and ultimately you get kind of a Java application layer that you guys are probably used to, writing Android apps in Java. So what does this mean? Well, it means underneath your phone is still a Linux box, which means you can do anything on there that you want, like get root access and do malicious evil things with that. The main difference compared to a personal machine, though, is that they're highly controlled, right? iOS doesn't give you shell access. You can't fire up my iPhone and go like, I'm gonna go to shell like I can on my laptop. That doesn't exist. Same thing kind of with Android. They're a little bit different. We'll get into the models in a moment here. But the big thing is that kind of the first things people wanted to do with mobile phones was they wanted to get out of this special access mode. They're like, wait, I have a computer in my pocket now, but you're not letting me use it like a computer in my pocket. I want a computer in my pocket. So the next step was, oh, by the way, the upper left guy there is Darwin, who is the the real version of BSD that OS X uses, and obviously Tux, the penguin. Was with Android, they're like, well, if I have a Linux machine in my pocket, then I want root access. That's kind of understandable. They're like, I want to load my own apps. I don't want to use the Google Play Store, any of that kind of thing. So they immediately worked on how can I get root access. Not maliciously. I mean, a few of you guys have probably rooted your phone or heard of friends that did for any reason. They want to customize it. You want to do all kinds of things that Google, for various reasons, said, no, we don't want you doing that by default. So it kind of benefits from the fact that Android is open source, so you can go look at all the source code for Android online, which means that people can very quickly find out, oh, I think I can get root access here, and then they would escalate up and ultimately get root access on their phone that lets you root your phone. It's easier on Android because that's all that's going on, is you're just running as a user, and then you want to get super user. So that's pretty simple escalation. Funnily enough, one of the very first Android phones, the HTC Dream, which I think was the G1 here in the States, someone figured out how to get root access that during boot up, the phone was just taking everything you typed on the keyboard and dropping it into a root shell. So if you typed reboot during your boot up, the phone would immediately stop and reboot again. And if you typed things like, move sudo into a place that I can access it as an app, it would just do that for you. That was pretty bad. So they have since fixed that. But it kind of continues. And every new OS, it's pretty quick for people to find ways to kind of get sudo access, and then now you've rooted your Android phone. The legality of this is really interesting. So they've had several rulings kind of in the 2010s about can you root your phone, because it seems like a violation of software agreements, that kind of thing. The bottom line is it doesn't violate copyright law. So it doesn't fall, because you're not violating any copyrights until you start stealing stuff with your rooted phone, which nobody ever does. Nobody ever installs pirated apps or anything like that, definitely. Until you start doing those, though, you're not breaking the law. They said, yeah, you can just do whatever you want with the software as long as you're not stealing anything. Interestingly, though, this doesn't apply to tablets. This only applies to phones because the court ruled that the term tablet was so poorly defined, they couldn't restrict it to what they wanted it to, and they're worried it would apply to getting illegal access on stuff that was not the intended purpose, like your Android tablet. So if you root your tablet, you're breaking the law. If you root your phone, you're cool. So you steal something. It's a little bit different on iOS. Apple is a lot more secure for a lot of reasons. They own the hardware, right? So Android is they make some software, and then a bunch of companies like Samsung say, we're going to make a phone and put Android on it. Apple says, well, no, we build this whole thing from the ground up in China, and then we ship it over here and put software on it. And that means they have a lot of control over what happens there. And you don't just run as a regular user like in Unix land where you just want to get super user access. You actually run with a lot of restrictions on you and a lot of things that you're not allowed to do. So you have to do something that's more complex called jailbreaking. It's kind of a reference to those of you who know of getting out of roots in Unix, where they change your root and they kind of put you in a little jail. And that's why you don't see them as often. Like Android rooting happens pretty quickly. A new version of Android comes out, someone figures out how to root it in a couple months. So far, nobody has released how to jailbreak iOS 9.1, 2, or 3. People have proven you can do it, but they haven't released it because so people have done it, and I don't think they have it. They either don't have it where they want it to be, or they're keeping it for their own purposes. And this is because it's really hard. Apple does some really, it's called the walled garden, because they kind of have like, oh, it's our little beautiful place. Oh, I lost my remote control powers. That's unfortunate. They have this kind of control over the device where they can do things at the hardware level, and if we were going to talk about that, it would look a lot like this chain of things. So there's a secure enclave, and Apple signs the bootloader, and there's a lot of really complex crypto stuff that I'm not going to talk about. Why? Because it's actually kind of its own talk. There's a lot of really complex things that Apple does there in crypto land that's really neat, and I would love to talk about, but I don't have time, nor do most of you, I'm guessing, care. If you do, you should come to some White Hat talks, because we do talk about that kind of thing. And especially, it's part of why the FBI had some trouble getting iPhones is because they're so well encrypted from the ground up, right? They have things like the hardware itself can be signed with certain kind of special keys that will then sign the next piece of software that loads, that signs the OS, that signs the apps. And they also do a lot of more complex things about when you're running apps as a user, you're actually stripped away of a lot of power. So it's not enough to just kind of break out and get root like you did on Android. There's some really interesting things there. One big thing is in iOS 9 and newer versions of OS X, they're bragging about a new rootless system where they set up certain system files that you would need to change in order to get kind of a jailbroken iPhone that a root user cannot access. So even like sudo would not get you access to this file. It's kind of set up in read-only mode when the OS gets installed, and the OS says, I don't have privilege to read this file, nobody does. Or not privilege to write the file. So those files will just be permanently there unless you could go into the hardware level and kind of flip some bits, which, unless you guys are really good with like a nanoscopic needle, I don't think any of you are, you wouldn't be able to get there. So let's talk about some fun exploits, because that's really what we're here for, right? We don't want to hear about people hacking stuff. So the first thing that happened was people were like, well, all right, everyone learned how to root their phone because they wanted like custom backgrounds, or they wanted to load some pirated apps or whatever. Well, it turns out a lot of the defaults on those were not secure. Like everyone's just like, oh, I'm just going to root my phone. Like your friend who knows nothing about programming roots their phone or jailbreaks their iPhone. And they kind of just leave everything as it was. And the first thing we see is iKee in around 2010 was this I think, student wanted to prove that everyone was being really lazy about jailbreaking their iPhones and not configuring things. Jailbreaking gave you SSH access to your cell phone. Right? Have you guys all used SSH? Anyone not know what that is? When you remotely log into a phone? Or log into a device. Well, now you have a Unix device, so you can SSH into the phone, which is fine if you set that up securely, which they did. They left the default password on there, so everyone can just log into your phone with the default password. Like everyone jailbroke it and then left it like jailbroken iPhone password. So he wrote a worm that went around and replaced your background with Rick Astley, and basically just rickrolled you. And then it would jump from phone to phone. It basically go to that phone, set up your background as Rick Astley, and then go to the next phone on your contacts list, SSH into that, and make that background like Rick Astley to kind of prove how insecure this was. Which was kind of funny. It was harmless for the most part. It was like saying, yo, you should change your password. A lot of people didn't get the message though, because hackers almost immediately took that code and put malicious things in it. They're like, well, this guy was nice about it. He's just like, you should change your password. Or at least Rick Astley thinks you should change your password. But future people, didn't change their password, or they didn't get the worm the first time, and new people came through and really hacked some phones pretty badly. It didn't affect regular iPhones yet, because they were still kind of secure around the protections Apple put in place. Jailbreaking kind of tears some of those down at your own peril. We did see a real virus go around Androids. I think it was spread through some illegitimate app stores, which is kind of a recurring theme we see in mobile security, is that on Android, there's the Play Store. You don't have to use the Play Store. That's a big part about Android. You can actually use third-party app stores. This is really common in China, where China has a bunch of regulations about what apps you can use, what you can see, and also because it might be faster to download from Chinese companies than from US companies through all the Chinese firewalls and that kind of thing, which we do see in the later exploit. And what happened there is, I think one app store has 100, I think they said that 33% of the apps on it were malware. So if you picked any app out of that store, 1/3 was malware, which was awful. Their actual Google Play Store has less than 1%. They're very good about picking stuff out. That one, it was actually really clever. It would go around and it would basically turn every phone into a botnet where it would just send messages to premium phone numbers. Like every time you text, you get billed a couple dollars that goes to whoever's phone number you text it to. And it was a Russian company, I believe, that was just collecting money off of this. They just got everyone's phone to pay them a few dollars, and it would jump from Chinese phone to Chinese phone. It was, obviously a pretty big market. So moving along from that, we see kind of another play on that infected app store idea. So I want to say it was around 2011, 2012, somebody got really clever and thought, well, instead of infecting the apps on these fake app stores, like all the Chinese app stores especially, what if we distributed a fake version of the dev tools? So I'm guessing you guys in the mobile app dev club have used XCode. At least a few of you probably have, right? So what happened is in China around this time, somebody figured out, well, I'm going to make a fake version of XCode that when you compile with it, it adds malicious code to the executable that you can't see unless you then take apart your executable, which I don't think anybody wants to take apart an IPA. It's awful. It's just compiled Objective-C code and XML and just awful stuff. So they relied on that. They said, hey, you should download it here. It's faster than the actual Apple App Store on Mac. And be like, oh yeah, it looks like the Apple Store. It's a faster link for Chinese downloads because it was actually apparently really slow to download from apple.com or the Apple official store. And people fell for it. They put links all over a bunch of the Apple forums, a bunch of iOS help forums. They downloaded this Xcode, which looked completely normal. All they did is they took the original one and modified it. And then they would make apps. They'd submit them to the App Store. Apple wouldn't notice the malware because it was not anywhere in the app. It was mostly in the compiled executable. So the code looked fine, and the app ran fine because they were able to control what was happening. Part of that malicious code was saying, talk to a server and we'll tell you what to do. And they would just tell it to do nothing for a while. And they found out that a whole pile of apps later on, when they realized what was going on, were infected. It was no good. And I think Apple had to go through and kind of purge the store of all these malicious apps because they were stealing users' information at this point, right? Because you're running an app that now has malware in it, and it turns out that iOS has a fair amount of vulnerabilities if you load an app that's malicious, right? It's harder to attack a phone you don't have a way into, but these guys found a way into it by basically making your app into their app when you compiled it. That was pretty clever. We see something kind of similar moving on, YiSpecter, which is kind of the most advanced iOS malware we've seen so far. Again, in China. China has a lot of problems with mobile security, for better or for worse. So these guys are really clever. So if you've ever done mobile dev, I actually did this at my job, you can, usually apps are signed by Apple. They get released into the App Store, and then your phone says, oh yeah, it's signed by Apple, I trust this, I can install it just fine. If you try to install anything else, it says it's not signed. With the exception of if you get a special certificate from Apple called an enterprise certificate. This is usually meant for like if a company wants a custom app for their company, like an internal, not on the App Store, like a IBM's corporate app or whatever. You check internal websites, the same idea. And what they would be able to do is they'd be able to sign it themselves and then distribute it by basically manually installing it to various phones. And what happens is iPhones these days, I think they're more obvious now as a result of this, but they usually just ask you, are you sure you want to open this application? It's not signed by Apple, it's signed by company. I did this for all of our apps because I didn't go on the App Store. We'd basically make iPads that were going to the booth. We'd just load our custom app onto it, and it would say, hey, App Delegates, the company I work for, made this app. Are you sure? And we'd just say yes, because we made it. So what was happening was it spread through a bunch of different ways. So they signed one app with this certificate, or a couple of apps with the certificate, so that at worst, when you did get it, you'd see this. Why would you get the app in the first place? A couple of different ways. Chinese ISPs are not always the most secure. A bunch of them have problems with man-in-the-middle attacks, which means that somebody can pay the internet service provider to say, hey, when people ask for this domain, you're going to route it to us instead. And then we'll pretend like we're that address. If I ask for google.com, you'll go to like Chinese fake google.com, which will then take whatever you asked for and ask Google for it and give it back. Right? They're kind of sitting in the middle, watching your traffic, relaying it for you, so you don't know they're there, but they can do things. Right? They can either just observe, which is kind of the passive case, or they can be more malicious. They can kind of modify what you're asking for. And that's exactly what they would do, is you'd ask for one app, and then they'd go and load this custom one they made themselves instead. They'd cough back the binary for it, and your phone would load that thinking it was coming from the App Store, and it wasn't. And then when you opened it, it was still somewhat signed, so your phone was like, all right, well, I'm not too worried. I'm just going to ask the user, are you sure you want to do this? And most people saw this message, like, oh, it must be a new thing with the App Store, and they just clicked yes. I believe it was originally marketed as a porn sharing app. classic malware. The really clever thing it did, though, so you could do that. It was also, there's a bunch of these grayware markets in China where they advertise, like, hey, download our app, promote it for us, and we'll give you some money. So they basically post one of these enterprise-signed apps, and you download it kind of outside of the store, and tell your friends, like, hey, I got this new shiny app, you should download it, right? And you get paid as people download it. Kind of like a freelance marketing for apps. So they put this up there, right? They're saying, hey, just try it out. And the main app itself doesn't seem too bad, especially because what it does is it loads 3 more apps. So part of it being self-signed means they can put stuff in it that Apple didn't verify. And part of what they did is they made calls into private frameworks that do things Apple would never normally let you do, like install other apps was the big one. So it would make a network call and it would try to load another app that I want to say Palo Alto Networks, who gives a few talks for White Hat every year, did a great rundown on it. And the first thing that it downloads is an app that hides, it allows other apps to hide their icons from the dashboard, right? You can do this. If your code does this, Apple will say, no, we're not going to let you do this on the App Store, right? And you have to be pretty clever because you're not even, it's not even tools that are kind of made public, but you can still find them and include them in your app. So because they're not verified, they can do this. So they install one other app that then hides itself and installs 2 more apps. One of them, I want to say, one of them is kind of like the master app that what it would do is it would replace other apps on your phone because now it has the power to call into the framework that handles installing and uninstalling from code other apps, right? There was like a framework like, package manager framework basically, where you could say, install this iPhone app. I have the file right here as code, and it would just do it. So they would install one app that hid the icon. One app would then serve ads. Whenever you open up another app, you get an ad. Like if I open up Facebook, I get an ad. Open up Google.com, I get an ad, right? Over other apps, because now they have pretty solid control over your phone. And a 4th app that would manage updates. So it would talk to the kind of virus server over time and say, are there any more updates, and it would install new stuff and patches as it went. Why is this really bad? Because you don't know they're there, right? As far as you know, you have the original app, and if you delete it, the other 3 parts will just reinstall it for you, and they'll hide it. And if you can't see the icon, then how do you delete it on iOS? You can't really. If you use a third-party tool, which there are a few to tell you, like, hey, your phone's running these apps, you would see extra apps listed. So they got really clever, and when it wasn't invisible, like if you were able to see it listed, it was also named things like clock, calendar, reminders. So even if you could kind of get past the fact that it hid itself on the home screen and saw the processes running, the icons and names would match that of system apps that you were already expecting to be there. So you had to realize, no, wait, that one's not signed by Apple. That's not my real app. It was really clever. It did a lot of, it stole a lot of stuff. I think it affected several thousand Chinese and Taiwanese phones. It didn't really make it over to the US because it was mostly distributed over Chinese networks. Like I mentioned, it kind of abused Chinese networks' kind of fragility as well as their App Store stuff. That's not to say we haven't seen things over in Android land. In fact, iOS, is, besides those ones, are kind of considered more secure. Android, as kind of a process of being a slightly weaker security model, has issues. But Stagefright's not one of them. Stagefright's is a classic C, like kind of C++ coding bug. Have you guys heard of buffer overflow attacks? And have any of you guys not heard of that and also not programmed in C? It's fine to raise your hand. OK. So when you're programming in C, you're kind of working at a lower level. You're just copying memory into blocks of memory. Like if I want to read a string in, I copy every character into a buffer. And if you don't do it right, you can copy past the end of the buffer, because C doesn't care. Like I just keep copying characters. Well, what's the big deal about this is characters can overwrite where we're storing the next piece of code to run. So when your function returns, the stack that you've kind of built up of that function, it returns. The processor looks for the next, where the previous instruction was left off at. And if you overwrite that value, it'll jump wherever it wants to. Like, oh, I should just go here for the next instruction, and it'll just jump wherever you tell it to. So the clever thing is to kind of figure out where that instruction would be, overwrite it with one that points back into your buffer or over to some code you know about, especially libraries. So some libraries have functions that you want to call. For instance, maybe I want to call, if you've programmed in C, you can change what process is running. Like you can make your process change into a different application, right? My C program can what's called exec for instance shell, and it'll just replace itself with the shell program. So if I know where exec is located in the libraries, like I know the libraries are loaded into some part of memory, and I can jump to there, and I can feed it shell. I can basically overflow your buffer, jump to the shell, and then now I have shell access to whatever device I was on. I've replaced, like my calculator app with shell access. So they're able to do this on Android, because remember, Android is at some level Linux. It's still there. There's still C code lying around. So it happens that it was in the media processing library called Stagefright. So there's Stagefright, the library, and then they called it Stagefright, the bug, to kind of represent this. Where if they feed you a bad MP4, like a video file, because of how it processed MP4s, you could slowly gain control of the memory in your program, and then ultimately jump to some malicious code. I think usually shell access or some other stuff. That's no good, especially because the way it worked was Stagefright was really great because it was like, oh, I'll be helpful for you. I'll try to pre-process images as they get to your phone so we can react faster, right? Also, as a result of this, it's also why it was written in C++ and not Java, for performance reasons. Also, it runs as a system user. So it's running at an elevated level of permissions because it wanted higher priority in processing and a variety of other reasons, right? Because Stagefright was shared amongst several apps for media processing. So it runs as kind of a shared super user, or just below root. So when you break out of Stagefright, the library, you now have elevated privileges. It's very easy to get from there to the full power of root control. That's no good, especially because all you had to do to load this MP4 was receive a text message with the MP4 in it. Didn't have to open it, didn't have to read it. You just had to receive it. And Stagefright, or Android would kind of automatically kick it over to Stagefright, say, hey, can you process this for me in case the user opens it up pretty soon? We want to have it ready to go. And I would own your phone right then and there. That's pretty bad. This was estimated to affect like 1 billion Android phones. And then Google kind of immediately coughed out that, no, they'd already patched most of it. There were apparently a lot of holes in Stagefright. It was a poorly written library that was used throughout Android from Android 2.2 onward. But they said that we've gone through and we patched all of them except for like one thing, and we have a different fix for that. That one thing turns out to be no good in Stagefright 2.0. So this is more recent. So Stagefright itself, it was kind of never really went that far, because by the time it came out, by the time they kind of analyzed what you could do with it, people determined it wasn't much of a threat. Everyone had either upgraded enough or Google had pushed enough patches that you were OK. You couldn't really be affected by it until some clever guys proved that you still could. So the one thing Google didn't patch, there was some other minor thing with how it's processing MP4s that the group said, like, hey, you didn't patch that, and Google was like, they just kind of missed it. And people, for a while, weren't too worried, because what Google had also done is they've done what's called address space location randomization. So it takes, when you load up an app, and this works on your computer too, if you've ever taken 337, they've talked about it. When you load a process, a bunch of things get loaded into memory at once. And you can't access anything belonging to another process in any good OS, which includes Linux. The first thing loaded is kind of like the fixed code. So all the libraries that you're going to use just kind of get copied into memory. And then they make room for your stack, where all your functions are kind of getting built up, and the heap, wherever you allocate memory for like new objects or see just new stuff. And a lot of buffer overflow attacks kind of work around knowing what that looks like and saying, well, I know that if these 4 libraries are loaded, they're always loaded exactly the same because they're always the same library. I know the exact address I need to jump to get shell or whatever. So what they do is they actually take those blocks and they kind of randomize them. They shift them around, they put them in random places so you don't know the address of the libraries, and it's very hard to guess it in theory. Because you can't just jump to an address now. You're like, all right, I can overwrite the address like right next to me where we're going next, but I don't really know what my memory looks like right now. I don't know where to go to kind of be malicious. But then they figure out there are ways to kind of get around that. So it actually sends you down, I think, a few different MP4s. One of them does the initial trashing and kind of figures out what version of Android are you running. So they know the ASLR is implemented by a tool. I'm forgetting the name right now, but the main thing is they know how it's configured. It's configured a certain way for every phone. Not each individual phone, but each device. So like Nexus 5s and Galaxy S6s. So they know the parameters for each phone, and they can figure out what phone you're running. They can then kind of take a look at where the memory looks like, what it looks like right now, and the later MP4s would further that, and ultimately they would figure out where the libraries had gone. They could kind of match up and say, if I'm running a Galaxy S6 and it's doing this right now, then the library will be here. Because they realized there are only 256 possibilities for where it moved it to, because it kind of just shifted it instead of randomizing. It would just shift whole blocks. So they figure out where the shift was, like a Caesar cipher, basically. Like if I'm changing A to C, I'm moving every character over 2 in my message. Same thing. They basically figured out what the shift was, and it's back. And worse, it was also exploiting an underlying library to Stagefright, like a libc kind of thing, which meant that they had even more power than before. They demonstrated this last month. They were able to show that if you routed to a different web page, because the browser uses this too, if they were able to route an Android user to a different web page, they would own them with Stagefright. in a matter of a few seconds. It would cough down MP4, crash the web page, another MP4, the thing reboots, they know where it's at, they cough down the last one that actually owns the phone. So all they have to do is route you to a malicious web page, and now they can take over your Android phone. No good. Google has worked on patching this. The big problem you'll see with Android phones about patches, though, is that unlike Apple, who can just say, all right, we patched it, we're pushing it out, you'll see your update on your phone tomorrow. Google simply patches the Android source code, and then all the manufacturers have to kind of rebuild it for their phone. So Samsung and Google's Nexus division, that kind of thing, take Android and they modify it to fit their phone, and then they give it back to AT&T and Verizon and so on, who modify it further. And that's where one of the big stop-ups happens. Is you already have this delay of going through the developers. The next delay is the carriers like to add those bloatware apps. Like if you bought a new Galaxy phone, you've probably seen like AT&T's apps or Verizon apps, those kind of things. I don't know if they still do them on the Galaxies necessarily, but you'll often see like those like AT&T's or Verizon's map service, and you can't delete that app because they want you to have it because they can charge you money for it. Well, they take a while to develop those and test those, which slows down patch releases, which means that your phone may not actually ultimately get the patch until months afterward. So Google might patch it immediately. Like bug gets, or exploit gets announced, Google patches it within the month, and then you get the patch 6 months later, which is really bad. And it's been kind of an ongoing complaint about Android phones and updates, because Google has pledged to be more active about it. They're updating every month, and they're saying that the Nexus phones will get it immediately afterward, but everybody else is kind of waiting for their carrier to give it to them. And it's kind of been a point of issue where even if you're kind of up to date, you're not. You guys probably saw this one last year. It was a lot of fun. A bunch of your roommates probably sent you this message to screw over your iPhone or maybe even your Mac. This is the same kind of idea, but it was a much more light problem. The main thing here is that this Unicode here, this Arabic, is really, really badly formatted. And when the iPhone tried to shorten it on your lock screen, like the ... it crashed. It couldn't handle it. Like the Unicode processor tried to shorten it and made it longer because the way the Arabic characters expand when you delete one. And it was like, oh, well, I gotta make it longer again. It makes it longer, and then it makes it shorter, makes it longer, makes it shorter, and ultimately it crashes. And the problem is the part of the code that crashed causes the app launcher, like the home screen, to crash. And Apple's approach to having the home screen crash is like, well, that's really bad. The home screen shouldn't have crashed, so just reboot. Okay, reboots, loads your text messages again, and crashes again, reboots again, and kind of keeps going for a while, because every time it reboots, it's like, oh, I'm going to read your text messages. I'm crashed. That's no good. We'll try again. And that was why it was kind of annoying. You couldn't really get much farther than this, although there are exploits like this that Apple patches pretty frequently before. But that's kind of the same idea, right? You see these kind of bugs everywhere, and they're kind of hard to avoid. But if you're smart, you can avoid them yourselves, and that's what Charnpreet's going to be talking about next. So that's all I have right now. I hope you guys had some fun learning about some interesting viruses on mobile.
So the crash would only actually happen when you opened up that message, right? It's
No.
not actually when you unlock your phone, because the messages are still encrypted at that point.
No, it crashes when it tries to show it on the lock screen.
The notification.
Yeah, the notification.
Oh.
And that's why it crashes the home page, is because it's part of the home page rather than the Messages app.
Yeah, okay.
So the home page, either the drop-down notification menu or your lock screen, tries to show like the preview of the app, and it crashed. And because that's kind of a meta app that's running, like your home screen launcher, when that crashes, the iPhone just goes, oh, that's bad, we should restart, because you can't launch any apps at that point.
So if you had banners hidden, this wouldn't affect you until you actually opened up messages?
No, it would come along your lock screen.
No, so if you have those hidden.
Yeah, if you had those hidden, it wouldn't affect you as much. Also, newer versions of iOS were already patched against this. It also depended on some other, like where it was. Occasionally, it wouldn't always do the expansion, so it wouldn't always be an issue. And once you read the message, it was fine. I think the Messages app itself could handle it just fine.
Just the banner screen.
Yeah, and that's why I kept restarting those, because it was crashing the launcher.
Okay.
And the launcher is what launches your apps, and that's bad. If that crashes, your phone's kind of unusable. That's why iOS's default is just restart. Yeah, so thank you for listening. Hope you guys learned some stuff. We're giving over to Charnpreet for his part of the talk.